All right, welcome back. And I've got some information up here for you. Two things you're familiar with. Sine t is y, cosine t is x. And the other four trigonometric functions, as promised, all six, are defined, like I said, similarly, but yet at the same time not quite so. So what I want us to do going forward is to recognize that tangent you can define in one of two ways. You can either call it sine over cosine, or you can call it y over x, right? Those two are equivalent because sine is y, cosine is x, so we can do it either way. So either it's the ratio of sine to cosine, or it's the ratio of y coordinate to x coordinate. And there is a use for tangent, and there is a reason why we do that. Now, the reciprocal functions, or the cofunctions as they might sometimes be referred to, cotangent is the reciprocal of tangent. So sine over cosine becomes cosine over sine, x over y. Cosecant's 1 over sine, so y becomes 1 over y. And secant is now 1 over cosine, it is 1 over x. That's fairly straightforward, fairly easy to work with. The only thing that you do have to make a mental note of is that cosecant does not go to cosine does not go to cosecant. Secant does not go to sine. That is not the case. Sine goes to cosecant. Cosine goes to secant. The best thing I can do to tell you about that is you always gain or lose a co as you go from function to cofunction. So cosine loses its co and goes to secant. Tangent gains a co, sine gains a co. I know, it's awful. It is what it is, though. The only real reason I can tell you why it's done that way is because, well, tangent to cotangent, that makes sense. But cosine, I can't go from cosine to cosine, because then what would the cofunction of sine be? So we have a dependence established from sine to cosine, and we just kind of rode ourselves into a corner, kind of painted ourselves into a corner. So we had to do something with secant and cosecant, and it was weird. And I apologize to you on behalf of all of mathematics, but we just got to live with it. So just make a note of this and keep it pretty close until you just know it. Because you need to be pretty familiar, especially by the end of the semester. Tangent is sine over cosine. Cotangent is cosine over sine. Those are things that you're just going to need to know. But what you need to do right now, as you get to know them, is just use them. So I just have one thing for us to do here. Let t be 4 pi over 3. I want you to find sine t, cosine t, tangent t, cosecant t, secant t, cotangent t. And as I have up here, one quick last thing to note. It can be possible for anything that's not sine or cosine to be undefined. Reason being, it is possible for sine or cosine to be 0. Right? Sine of 0 is 0, cosine of pi over 2 is 0, because the x and y coordinates irrespectively are 0 at those points. Well, that's fine, but for tangent, I'm in trouble if cosine is 0. Right? Because cosine is 0, I have some number divided by 0, it's undefined. Similarly for secant. On the other hand, cosecant and cotangent are both 0 whenever sine is 0. I'm sorry, they're both undefined whenever sine is 0. Goodness, that was embarrassing. They're both undefined when sine is 0, so you have to be careful. It's not always the case that all 6 functions will be defined. That said, you can still do something with them. Specifically say they're undefined there. So, as before, as we have been doing, let's find our terminal point, find where it is, get the actual coordinates using a reference number to the reference point in the first quadrant, write our new coordinates down, and use those coordinates to find all of our trigonometric outputs. So if I were to be on the unit circle, there's my beautiful circle. You know how it's a circle? I know it's a circle because I have just said it's a circle. So, that's my circle. And if I were to go 4 pi over 3, that starts here. This is 3 pi over 3. So 4 pi over 3 should be about here. Now, the reference number for that, to get back to the x-axis, I would have to go pi over 3 back. So the point I'm going to refer to is the point generated by moving pi over 3. And that point, in case you forgot, is 1/2 comma root 3 over 2. 1/2 comma root 3 over 2. So the 1/2 is cosine. The root 3 over 2 is sine. Only difference now is we're in the third quadrant. So everything's negative, both x and y. So cosine of 4 pi over 3 is now negative 1/2. And sine of 4 pi over 3 is now negative root 3 over 2. So we got those two things. I'm going to hide this now. It is beautiful art, but it has to go away. So we've got sine being negative root 3 over 2. We've got cosine being negative 1/2. And tangent is y over x. It is sine over cosine. It is the ratio of those two coordinates. So I take the one and divide into it the other. And this is a compound fraction, as they're called. I have a fraction over a fraction. And if you're unfamiliar with how to work with that, or it's been a while, the best way I can describe it is saying, okay, so I'm taking something, dividing it by something. That is the same as multiplying by its reciprocal. So you change this to multiplying and you flip the fraction. Now I've got negative root 3 over 2 times negative 2 over 1. The 2's cancel, the negatives cancel. That's right, because negative times negative is positive. So your final value for tangent is just the square root of 3. Pretty cool. Of course, we're only halfway done, right? We're only halfway there. The other thing is the reciprocal functions. But we already have the thing we're taking reciprocals of, so let's just plug those in. Just write those in, right? And then take reciprocals, because that's all we would have to do. We don't have to do anything fancy or beyond that for these. So cosecant's 1 over sine. 1 over negative root 3 over 2. So we can kind of simplify that, again, this being a compound fraction, to be negative 2 over root 3. Which I'm fine with this. Although aesthetically, people like rationalized denominators, so you could also call it negative 2 root 3 over 3. Either of these are fine by me. This one less so. This 1 over a fraction, that's too much. That's just too awkward. But either of these are fine. Similarly, negative 1 over 1/2 or 1 over negative 1/2 becomes negative 2. And I think you agree with me pretty quickly that this is a lot better to look at than that. And that's why I kind of like claiming up compound fractions. Radicands or radicals in the denominators, that's whatever. But I do like having cleaned up fractions. And then lastly, cotangent is 1 over tangent. So the 1 over root 3 now for cotangent. Or if you have to rationalize it, root 3 over 3. Again, either is fine. And that's it. We just found all the 6 trigonometric functions for 4 pi over 3. And we're going to find on your own time and in class that that's how you can find any trig function for any value t. You find your point, you find your coordinates, and then you just apply based on the definitions we have here. Of course, as I had mentioned, if sine is 0, that's fine, but now you're going to have undefined cotangent and undefined cosecant, which, like I said, is fine. You just have to be aware of it. So, look over this a little bit between now and class, and I'll see you then. Just one last question for you. What was confusing about this? What was the most difficult thing for you to grasp between the last couple videos, or this and the last video? And let me know. Fill that in here, and I will look at that before class and see what we can do. So you guys have a good one. See you soon.